We have another trinomial here, so we gotta complete the square first. Okay, to complete the square with the x squared minus 2x, I need a plus 1. I have a 2 there, so I can just say, I can split the 2 into 1 plus 1. Group these three, you get x minus 1 squared plus 1. Okay, so let me write it like that first. X squared plus 1, right? We have x minus 1 squared plus 1, okay, all squared. Okay, so typically, we don't have a two term on the top like that. So you know what? Let's split it. Let's split the fraction so that we don't have two terms, right? So that numerator over what we have on the bottom. Okay, and then a plus just 1 over what we have on the bottom. Okay, let's make the substitution. The substitution here, because we have variable squared first, is to let x minus 1 equal to tangent of theta. So you get dx is equal to secant squared theta d theta. Okay, let's make the substitution. Okay, so x squared, that's going to be tangent theta plus 1 squared, right? Dx is going to be secant squared theta d theta. And the bottom here is going to be a tangent squared theta plus 1 squared, okay, plus 1 over, the bottom just going to be tangent squared theta plus 1 squared. Okay. Okay, so that right there, the bottom is going to become secant squared theta, and then another square, so it's going to be power of 4. Okay, here it's just going to be secant to the power of 4 theta. Okay, oops, I wrote dx there, should be d theta. Okay, so that'll get reduced. And then we get, okay, over secant squared theta. Okay, this one I'm going to write it as a cosine to the power of 4 theta. Okay, because I have two terms here in a bracket, I'm going to expand that. So we're going to get tangent squared theta. Okay, tangent squared theta plus 2 tangent of theta plus 1 all over, okay, all over secant. Okay. Alright, so tangent. So tangent is sine over cosine, and secant is 1 over cosine, which is the same as sine. So sine over cosine times by cosine. So this is actually the cosine is going to cancel out. It's going to give you, okay, sine squared theta. Okay, that's the first one. Plus this one here. Okay, so we have 2. And we have sine theta over cosine of theta. So divide by, right? Divide by secant is the same thing as times by cosine, okay? Times by cosine squared theta, right? Because this is 1 over cosine. So that's gonna cancel out. Okay, and lastly, this one is just integration of cosine squared theta d theta. And we have, of course, one more left at the end there. Alright. Okay, so I just cleaned up this line to get this. Now take a careful look. Is there anything we can do here to simplify our integration process? Okay, one is that we can combine these two. What's sine squared theta plus cosine squared theta? That's going to be exactly 1. Right? If you add those two, you get 1. So that's the same thing as this. Okay, that's the first thing. This here is actually equivalent to, using the double angle of sine, it's sine of 2 theta. So that's the second thing that we can do to simplify the antiderivative process. And this one here, this is the only one there isn't a simple process. We have to lower the power using a double angle formula for cosine twice. Okay, so this is cosine, you think of it as a cosine squared theta to the power of 2d theta. Okay, but cosine squared theta is equal to, okay, is equal to half of 1 plus cosine of 2 theta. Okay, so this right here is just going to be simply theta. That right there is going to be minus half of cosine of 2 theta. Okay, this one I'm not close to being done with it yet. First I need to replace it with half of 1 plus cosine 2 theta and all squared. Okay, square the half and the bracket, we get a quarter. Square down, you get 1 plus 2 cosine of 2 theta. And then you get a cosine 2 theta squared. Okay, so this and this you can find the antiderivative of now. Theta minus half cosine of 2 theta, a quarter of theta, and that's going to be a quarter of sine. So this, the antiderivative, this is going to be sine of 2 theta. Okay, so we just have a quarter of cosine squared 2 theta left over. Okay, so let's combine these two. 5 over 4 theta. Okay, and the other two we cannot combine. Okay, now this here, it can be replaced with, again, a half, 1 plus, this time a double angle of 2 theta, which is going to be cosine of 4 theta. Alright, now we're almost done. Alright, so it's 5 over 4 theta. Alright, that's going to be 1 over 8. Integrate the 1, you get again theta. Again, 1 over 8. This is going to be sine of 4 theta divided by 4. Okay, that's the antiderivative cosine of 4 theta. Okay, in the end, plus constant. Okay, so let me just clean that up. The only thing we can really clean up is combine these two to give you. Okay, so you get that. These two I just copy and pasted. And that right there is going to be 1 over 32 sine of 4 theta. So theta is missing there, plus constant. Now we have to change this all back into in terms of x. And we had originally, the original substitution we made was that tangent theta was equal to, okay, equal to x minus 1. Okay, so that means, right, here's our theta, x minus 1, 1. So we're going to get x minus 1 squared plus 1 square root. Okay, the theta is easy to replace. It's going to be 7 over 8 arctan of x minus 1. Okay, so cosine 2 theta and sine 2 theta is a little bit more complicated. Let me do it on the side here. Okay, so recall, right? Sine of 2 theta is equal to 2 sine of theta cosine of theta. So we need to use this to express in terms of x. So sine of theta is x minus 1, right, x minus 1 squared plus 1. Cosine is 1 over that. So 1 over the same thing. So we get 2 times x minus 1 all over just x minus 1 squared plus 1. Okay, good. Maybe we can expand that and maybe simplify it. This is, well, the top don't expand. The bottom, if you do expand, you get x squared minus 2x plus 1 plus 1 plus 2. Okay. Now for cosine of 2 theta is cosine squared theta minus sine squared theta from the double angle formulas. Okay, so the cosine ratio is going to be 1 over this. So if you square that, you're going to get just this. So remember, this expanded was this right there, so I'm going to just copy that down. squared minus 2x plus. Okay, so cosine squared theta is this. If you get that divided by that squared, okay, sine is going to be x minus 1 squared over whatever we have at the bottom, which is exactly this one again if you square it. Okay, so the bottom is just x squared minus 2x plus 2. The top 1 minus, that's a difference of squares, it's 1 minus x plus 1. 1 plus x minus 1. Alright, so that gives you, right, that's 2 minus x. That's going to give you x. Like that. Okay. Alright, we're almost done. So we can replace, here, we can replace the cosine with, okay, that. I just copy and pasted it. Okay, plus 1 over 4 sine of 2 theta, okay, which is that. Okay, and then plus 1 over 32 sine of 4 theta is actually, right, sine of 4 theta is actually 2 times by sine of 2 theta and cosine of 2 theta. We just found sine of 2 theta, which was this pink part, and cosine of 2 theta was this pink part. Okay, so we just have to multiply those two and put it in there. Okay, so alright, finally let me just write the entire answer here. 7 over 8. Okay, so that's going to be minus, let me multiply the minus in, and you actually get x minus 2, it looks nicer, times by x, all over 2 times x squared minus 2x plus 2. That'll get reduced, so you have x minus 1 on top, at the bottom we have 2 again. Okay, plus that'll reduce you 1 over 16, and we have to just multiply the 2 pink parts. So if we just multiply the top, okay, we get a 2x x minus 1 times by 2 minus x, and the bottom is just x squared minus 2x plus 2 squared, okay, plus constant. Okay, so I guess if you're trying to simplify a little bit more, I mean, I'm sure by now if you're following with me so far, you're tired of this question already. It's so long. These two have same base, right? So we can put that all on as one fraction instead of 2 separate fractions like that. Okay, and you get x squared minus 2x plus x, so that gives you minus x and minus 1 on top. Okay, this gets reduced to give you 1 over 8. Alright, that's it. I'm going to stop there.